Right, so this is my week 3 problem 1 video explainer. So in this problem we have a bike wheel of radius small r and mass small m, and it's connected to an axle on a string or a rope, and the distance from the center of mass to the end of the axle is capital R. So first we are trying to find the direction of the angular momentum and also the initial angular momentum. So the way I approach this is I first solved for the inertia, which we know is inertia of the wheel, which we know is 1/2 mass velocity squared, and we know that angular momentum is 1/2, so it's 1/2 mass velocity squared times the angular velocity, and that 1/2 uh, mass velocity squared is the inertia. So after doing a little bit of simplification, we find that the mass times the angular velocity times v squared over 2 is equal to the angular momentum. And in terms of the direction, so the direction of the angular momentum is going to be perpendicular to the line or the string joining the axle and the wheel. So in this case, it would be the z-axis, and this can be denoted with this little equation I wrote, which is the angular momentum is equal to the inertia times the angular velocity, and with that little k at the end denoting the direction. So, so the wheel is turning counterclockwise when viewed from the positive x direction. So now we're trying to find the torque direction. So the torque can be, I guess it can be denoted as the change in the angular momentum with the change in time. So this would be that the torque would be going in the same direction as the change in angular momentum, so also in the z-axis. So and now we're trying to find the period of precession. We know that omega, which is going to be equal to the precession frequency, and that is just a change in the orientation of the rotation axis. I just wrote that down there. So we know that mgr over mr squared times the angular velocity, and the masses can cancel out there, so that's going to be equal to the g times big R, which is the length of the string from the center of the mass to the end of the axle, and that gives us the frequency. So to find the period, it's the 2 pi over the frequency, and I'm sure that can be simplified out probably a little further, but that's what I got for the period. Some of the difficulties with this problem, we're just trying to, because you were not given actual numbers, just being able to conceptualize it in terms of like different axes and different directions, I found that a little tricky, and I probably made some mistakes as well there. So that was definitely part of the tricky part of this problem, just knowing in regard to like what direction all the components are going in. And this just relates to what we've been doing in class, just more in just in line with the ideas of angular momentum, angular velocity, inertia, the rotation, and yeah, thank you.